Back in the tent workshop today, I'm standing here in front of my slide compound miter saw. I've had it for about 20 years. Global manufacturing company brand, made in China. The global manufacturing company GMC went out of business in the GFC, so about 10 or 11 years ago. It's been quite a useful machine. The important thing with a machine like this is fitting with a cheap machine, is fitting a decent blade and bearing preload on the spindle. Pretty well after that, it's just about making sure that it cuts straight. However, there is a problem, which brings us to today's issue. Once again, I'd like to welcome you to another episode on the whitedoggarage YouTube channel. In this episode, we're going to be looking at a repair to the catch bag chute on this miter saw. So what's happened in the fullness of time is that it's broken off. And it's got to the stage where you start up the saw and the whole thing just goes whoosh into the wilderness. What we're going to do is take it off and send it to the metal shop to get a new one made from steel. We'll need to know the screw positions, and there's an easy way to do this. Let's take a piece of paper, mount it firmly, and then with my pencil I'll just do a tracing. And that shows you an outline of where the mount goes in, plus the two screw positions in relation to that. Okay, we're back in the metal shop now, and we're going to be making a metal replacement for this plastic exhaust pipe, I suppose you'd call it, sawdust chute for the miter saw. And that's going to be the focus of this video. I've been looking through my scrap pile. I found a nice piece of pipe that is the diameter, or pretty well the diameter of the pipe that I need. Now, it's thin wall tubing. It can be bent, but I'm not going to do a bend. I'm merely going to make a cut and join to produce the bend. And of course, to do this, I need to know my angle. And if I put a protractor across here, I see the angle is 32 degrees. Now, what we need to know is what I call the half angle. And the half angle of 32 degrees is 16 degrees. It's that easy, divide it by 2. And that allows us to produce a bend to match this one. To explain to you the concept of half angles and just how relevant it is here, I've resorted to the whiteboard, and we're going to do a bit of high school geometry. So if we look at our pipe side on, we've got a top there, a bottom there, and those two lines are equally separated, and they're what's known as parallel lines. I've drawn a set of parallel lines here. If we draw a line through like that, the angle here is equal to the angle there. Let's call them theta and theta. So we draw a line through, and that angle there equals that angle there. And let's rotate these two 180 degrees. That's halfway round. So we've rotated them now, and now those two angles are together, and if we slide them to they actually join, the angle there becomes 2 theta. So when we're talking about a half angle, that's half of 2 theta and that's half of 2 theta. So we know that our angle of our piece of pipe is 32 degrees and the half angle is 16. If we make our cut at 16 degrees, turn it 180 degrees and join it up, our angle there will be 32 degrees. So we're over at the cold cut saw now, and we're just changing that angle to 16 degrees. We've made the cut, and now if we turn and match our angles, something like that, and bring the other one there, you can see it's a pretty good match. All we have to do now is weld it in place, and we'll also need, well, obviously we need to cut another section off, and we need to produce our flat back. I've just finished creating the flat section here, which is the match for there. I just had to machine a little bit around here so that I got the diameter down to match. So we're all set to go with the next step. Now I've made the cut through the straight section of pipe, and it's cut at the half angle. I've drawn a line here, which is this side, marks this side. I want it to go 180 degrees around, and I have drawn a line that matches that 180 degrees, and that will give me the angle I need to match the original sawdust chute. What I've also done is cut a section of flat which will form the bracket which goes on the side, which holds it in place. I started by tacking the joint. I used oxy-acetylene, also called oxy-fuel welding, for this. The reason for this is the pipe is galvanised, thin wall, and has been lying around here for years, which means it's partly oxidised as well. Oxy-acetylene deals well with this situation. You don't need to clean it up before you start. The flame takes care of all the impurities for you. I first did 3 tacks, roughly equally spaced around the joint. Then I welded it out. With the joint done, it was on to welding on the mounting plate. This was only welded on the top side as the plate needs to sit flat on the miter saw base. With the welding out of the way, it was on to drilling the holes in the mounting plate for the screws. Remember the tracing that was made? This is where it gets used. To preserve the orientation, the now trimmed tracing was placed face down on the bracket. The screw hole positions, which had been previously traced to the back of the tracing, were then marked with a centre punch. Then it was off to the bench drill, where I drilled the two 6mm diameter holes. And now with the wonders of videography, we've got the finished metal product. And look, they even painted it. Goes in here like so. Fit the screws. Now that all fitted, nice and solid, and ready to do some more cutting. Well, I hope you enjoyed that video, and if you did, I'd welcome a thumbs up. And as always, if you haven't already subscribed, I'd love your subscription as well. Thank you once again. Bye.